Question 3. So it's still using the superposition law. So we are going to use the same logics that we used in the previous exercise. Okay, we have step 1. So in step 1 we are going to consider this source, and then we are going to close the second one. And as you can see, these two sources are different. So this is a source of current, but this is a source of voltage. So what we are going to do here is we are going to close 500 volts and consider 30 amp only. So now what's gonna be the actual circuit if we close this source and then you consider that source here? So the actual circuit will have that form. So we have the source of current, so here we have a resistor, here, and then we have another resistor, and here we won't have any source of voltage, so we'll just make a straight line. So there's nothing here because we just closed that voltage. So now we are going to put the value of each resistance. So we have 9 ohm there, so we have 9 ohm all over, and then the value of this current is 30 amp. So another way, that is the total current. So here we know what the total current is, so we don't need to calculate the equivalent resistance, because we calculate the total resistance when we don't have the total current, but here the total current is given. So we have the main branch, which splits into two branches. So we have the first branch and the second branch here, but I'm concerned to find the current in the second branch here, in the branch of where we have to determine the line current. So I'm gonna say the line current will be equal to, I have the total currents here, which is equal to 30, and then I multiply by. So now I need to specify the resistance that are in parallel. So I have the first the current is coming from the supply, which is called IT. So now at this point we have the current that flows in this resistor, and the remaining current will flow in this entire circuit. And then so we have two blocks here. So at the bottom I'm gonna add these two blocks. So the first block is 9 ohm plus the second block I haven't yet determined it. So for now I'm gonna put I will just write down the parentheses or the brackets. So now here, as I'm calculating the current, I need to calculate the current flowing through the main block. Then I'm gonna use the opposite. So instead of using that block, I'm gonna use the second block. So the second block will be on top. So that block here is the same as that one, and is the same as that one. So now I need to look inside this block here. So inside this block I can say that we have these two resistors that are in parallel, and so we have the first block and the second block, because the current is coming from this side. At this point the current splits, so one part goes cross in this resistor and another part will cross in that one, and then at this point the total current will get restituted. So we have the same current that gonna also pass in this resistor. So here I can see that these two are in parallel since the current split. So we are going to say, so but if we look at these two blocks inside, so we have the first block and the second blocks, they are in series because the same current that pass in the current that passes in the main block is the same current that crosses the second block. So now I'm gonna, if I replace, I'm gonna have, so since these two are in series, so the total the equivalent resistance of these two will be the sum. So I'm gonna have 4, oh sorry, that is 9 ohm. So I have 9 plus, so here I need to find the equivalent resistance of the blue block. So that's value is the same as that one, so we need to have at the bottom the same bracket. So we have 9 plus. So now I need to look at, I need to look inside the green block. So in the green block I've realized that, I mean in the blue block I've realized that I have two resistors that are in parallel. So I have that resistance and that one. So since they are in parallel, so the equivalent resistance will be equal to 1/9 for the first resistance, and then for the second resistance we have also 1/9, and I need to use the inverse since we are determining the equivalent resistance for two resistors that are in parallel. So same thing here, I have that one. So now I just need to compute this expression. So I'm gonna have IL, which is equal to 30 multiplied by, I have 9 plus, I'm gonna replace all this by one resistance. So the value will be, so if I compute all this, I'm gonna get 4.5, and then here I'm gonna have that 9 plus I have another 9 inside here, and then I have that one which is 4.5. so if I carry on again, I'm gonna get the total current. If I compute the whole thing here, I'm gonna get the total I'm gonna get the current passing in 9 ohm, which is equal to 18 amp. So that is in step 1. So here I will just put a 1 there in order to signify that we are in step 1. So now I'm gonna go to step 2. So in step 2 we are going to consider the 500 voltage source, and we are going to remove the 30 amp source here. So here we want short circuit that current, because that is a source of current. If it is a source of current, we'll just remove instead of short circuiting. So in other words, the actual diagram will be, so we are going to consider only this part. So we won't extend a straight line as we did with other example, because in other example we are dealing with the source of voltage only. If it is a source of voltage, then we are going to close the source. But if it is in case we have a source of current, so we'll just remove it. In other words, we are going to consider only this part. So it means we neglect the other part. So if I redraw it, I'm gonna have my actual circuit. So I have 9 ohm, so I have 9 ohm all over. So that is 500 volts. Yeah, that's gonna be my actual circuit. So we have the main current, or the total current, that is coming from the supply voltage. So I'm gonna call that I total. So since we are in step 2, I can maybe call it I total 2. So at this point we have one part of current. I'm gonna call it that I1, and then we have I2. So I2 is what they want us, no, they want us to determine I1, because I1 is the current. As you can see, this point is that one. So at this point the main currents split. So we have the first current and the second current. So the second current, the first current is the same value as IL, because this source is removed already. So all this part here is removed. So we only consider this part. So why do we remove? Because it's the source of current, not a source of voltage. As we can see here, we have 30 amp, we don't have 30 volt. So now I'm gonna apply the same logic, the same steps that are usually used. So to find I2, I'll first need to determine the total current. So I'm gonna say the total current is equal to the supply voltage divided by the equivalent resistance. So here I need to find the equivalent resistance. So to find the equivalent resistance, I can see that we have the total current which is coming from this voltage and passes 0.9 ohm. So that is the phase resistance. And then at this point we have the current that's split into two branches. So we have this current that is called I1. So that current here is the same. So the current passing in this resistance, in this resistor, is the same as the current that is passing through this resistor. Since it is the same current, I can say that these resistors are in series because they are all crossed by the same current, so they are in series. And so I can say that these two resistors are in series, and then I can replace them by one single resistance. So now we can say that the current that passes through all this resistance, all this resistor, all this block is not the same as that current. So in other way, these two are in parallel. So now the red block is made of two blocks that are in parallel. So we have the first block and the second block, and these two red blocks are connected in series. So now what's gonna be the equivalent resistance? The equivalent resistance will be equal to, so we have these two resistors that are in series. So we have the first resistance, which is 9. So since they are in series, we are going to add them. So we take that resistance, we say that resistance here plus that one. So I'm gonna replace the whole resistance here by the bracket. So now if we go inside this bracket, we have two resistors that are in parallel. So we have the first one and the second one. So the first one is 9 ohm. So I have 9. Since they are in parallel, I need to use that symbol. So that 9 is in parallel with these two here. So these two are connected in series. So since they are connected in series, the equivalent resistance will be the sum of these two. So I'm going to have 9 plus 9, and then we close. So now we need to compute this expression. So we first look at the values that are separated by. So we first look at the bracket that is inside, that is more inside. So we can see that the blue bracket is more inside. So I'm going to start with that one. So we have 9 plus 9, we get 18. So I'm going to replace it by 18. And then if we simplify this, we are going to have, So I'm going to replace all this by the expression of parallel resistance. So we are going to have 1 over 9 plus 1 over 18 and the inverse. So that is the meaning of this bracket here. So I'm going to have 9 plus, so if I compute this, I'm gonna get, so I have 1 over 9 so I get 1 over 9 plus 1 over 18 and everything the inverse plus 9. So I'm gonna end up with the value which is equal to 15 ohm. So that 15 ohm represents the total resistance. So now to find the total current, I'm gonna need to use this formula. So therefore I total is equal to the supply voltage divided by the total resistance, which is equal to 15. So I get 33.333 amp. So that is the total current. It means this current here. So we know what the total current is. So the total current is that one here, which is equal to 33.333 amp. So that current is the same as that one here. So at this point the current will split into two branches. So we have the first current and the second current. So we have said that these resistance are in series since they are caused by the same current, and these two are in parallel. So these two resistors are in parallel. So we are not considering this part. So now how to find IL? IL is the line current flowing in this block here. So I'm going to say IL is equal to, so IL is the derived current of the I total. So we have the total current here. So IL is, so we are going to use the total current and then we multiply by the sum of the resistance, because IL is flowing in this block here. This block is made of the resistance that are connected in series. So the total resistance, since they are in series, the total resistance will be the sum. So we have 9 plus 9, which is 18. So that 18 is the resistance of the first block. And then we have the opposite current of I1, which is I2. Since we need to determine I1, we are going to consider these two resistance. So we first have the first resistance, which is 18, and the second one is 9. And then here, am I gonna use 18 or 9 on top? I'm gonna use 9. Why 9? Because IL, the currents in this resistor, because the current is passing through this resistor. So that resistor, the opposite resistance of that one is 9. So 9 is, so that block is in opposition of the resistor through which the current that you are looking for is flowing. So I'm going to use 9. So I'm going to use that block on top. So if we had to calculate the current flowing through this resistor, then you are going to use this block on top. In other words, we are going to instead of 9 here, we're going to have 18, because the equivalent resistance of this block is 18. But in that case, we need to determine the currents here in this block. So if we use the calculator, we're going to get 11.111 amp. So that is IL2. Why IL2? Because we are in step 2. We're still in step 2. So now in step 3 we are going to add the two currents. It means the line current that we have determined in step 1 and the line current that we have found in step 2. So here we are going to say we have the phase current, the current that we get from step 1, which is equivalent to so that is 18. So we have 18 amp plus 11.11. So that represents I2. So if we add these two currents, we get 29.101 amp. So that represents so that is the current IL. So it means the line current in 9 ohm resistor. That's it.